Hello students. Now next topic in our curriculum is queue as a data structure. So last time we studied stack as a data structure. So on the similar line, queue is also one type of data structure. So queue is linear data structure in which elements are added and removed in particular order. Linear, it means in sequential manner, one after another, right? So what is difference between queue and stack then? So queue follows first in first out principle. It means the element which added first will be removed first. If you compare this with stack, stack follows first in last out principle, right? So as the element which added first are removed first, so insertion and deletion done from different sides. In stack, insertion and deletion done only from top side, right? So in queue, insertion done from rear side, means from back side, and deletion done from the front side. Okay. Now let's look up at the example. So this is the example of queue. You can say there is a library, and in the library there is a queue of students. The students which comes first will get first response from the librarian, and the new student get added from the back side. So the student which holding a books in the first number is the front of the queue, and the student which stand at the last is nothing but rear of the queue. Now next is how queue can be represented in memory. So in order to represent queue in computer memory, we can use the concept of array, right? So by using the concept of array and some C programming features, we can implement concept of queue in C programming. So this is the example. You can say there is a queue with capacity or with size 8 elements starting from 0 to 7. So when new elements comes in queue, let's say 10, so it is goes to index number 0, then 20 index number 1, 30 index number 2. So your rear gate increase, okay, increase by 1. So if new elements come, then it will go to 3, third index location. And if I want to remove the element from the queue, then from the front side elements get removed. So there are two operations in queue. One is enqueue and second one is dequeue. Like in the stack, we are using push and pop. So first operation is enqueue. Oh, now what is enqueue? Adding or inserting new element in queue is called as a enqueue. If you want to add new element in existing queue or in empty queue, then that kind of operation is called as enqueue. Only the one thing you have to remember is that if the queue is full, then new element cannot be added in the queue, and new element always added at the rear position, not in middle somewhere. Rear pointer points the location, at that location new element get added. So this is called as a enqueue operation. So see this example. There is an empty queue with capacity of 4 elements. I say enqueue 7. So 7 get added in the first block, then enqueue 4, second block, enqueue 9, third block. So in this way elements get added in the queue. Second operation with respect to queue is nothing but dequeue. Now what is dequeue? D means delete. Removing existing element from queue is called as a dequeue operation. So if you want to remove a element from the queue, then you can use dequeue operation. and the element always removed from which side? From the front side. Okay, and one thing you have to remember, if your queue is empty, then element cannot be removed from the queue. Okay, so these are the two operations. Now see the example. There is a queue with elements 1 2 3 4 5 6. So when I say dq, 1 get removed. When I say dq, 2, then 3, then 4, then 5. So from the front side, elements get removed from the queue. So next thing comes, how queue can be act as abstract data type. So it having n number of operations, that's why it act as a ADT, that is abstract data type. So first one is queue operation, so it will create a new queue, that is a empty queue. Second operation is enqueue. Now in this case we don't specify any position because it gets added in the specified location, so we only pass one parameter, that which elements you have to, or which item you have to insert in queue. Next operation is dq, so no parameter you have to pass, the element or the item which present at the front side will get removed. Then is empty, so whether your queue is empty or not, so for that purpose you can use is empty. Whether queue is full or not, for that purpose you can use is full. And size means how many number of items present in the queue. Okay, so it will return an integer value, that is the size of queue. Capacity is different, size is different. So there are two conditions. If you want to implement C program for the queue, then two conditions you have to check. One is queue overflow or queue full, and second one is queue underflow and queue empty. So queue overflow or full means what? When the queue is full and user still try to enqueue an element, in the condition is called as a queue full. So queue is full, you still want to add an element, so it is not possible, so it will generate the error that queue overflow or queue full. Now queue underflow. When the queue is empty and an user try to dequeue element from the queue, dequeue means want to remove the element, the condition is called queue underflow or queue empty. So a queue doesn't contain any elements and still you say dequeue, so no element is there at the front location to remove from the queue. So at that time this error get generated. So this is the algorithm in the C program for enqueue operation. First we have to check whether the queue is full. If the queue is full, then display the error message that element cannot be inserted. If it is not, queue is not full, then increment the real pointer by 1 and at real location please place the item that you want to enqueue, right? And for dequeue operation, first you have to check queue empty condition. If queue is empty, then say error message that queue is empty, no element can be removed from the queue. And if the queue was not empty, then first increment the pointer because front is at 0th index location, right? So take the data from front location and just increment the pointer from front to front plus 1. So now the next element will be the first element and automatically that element will get removed, right? So these empty conditions will not be filled, please keep in mind. So in this way you can perform dequeue operation. Now there are some types of queue. So first type is linear queue. So linear queue means simple operation queue in which insertion occurs at the rear of the list and deletion occurs at the front of the list. So that's we see here. Next type of queue is circular queue. So circular queue means last node is connected to the first node. Okay. Now in the linear queue, last node is not connected to first one in sequential manner. But in circular queue, last node is connected to the first node. Now what is the advantage of circular queue? even the last element is occupied, new value can be inserted behind it in the first empty element of the array. Means empty locations of the queue can be occupied, can be fulfilled, can be fully utilized by using circular queue. So this is the example of circular queue. Let's say in step 1, delete x, no element is there, so it will generate an error. Second, insert ABC, so ABC get added. Insert DEFG get added. Delete A and B, so A and B get removed, and insert H, so H is there. Now Q is empty. Delete C and insert I, so as it is connected to first element, right? So I get added at the first index location. So that is the advantage of circular queue, which is not possible in linear queue. Next type of queue is priority queue. So priority queue means inserting an element, we assign priority to the particular element, and while deleting means while giving preference for the operation, highest priority element will be deleted first. And if both the elements having same priority, then whichever the comes in first in a queue will get first response. So let's say senior citizens are there, they are having highest priority of operation, so they are getting first response. Like this we can implement priority queue also. Now there are other type of queue also, that is DQ. Okay, so DQ means double-ended queue, means insertion and deletion is also possible from the one side also. So in that first type is input restricted queue. Okay, input restricted DQ means it allows insertion at only one end, but deletion is possible from the both the end. And output restricted queue means what? Deletion is only on one end, but insertion from the both the side is possible. So that is the concept of DQ. Now at which points the queue is applicable? In many applications, queue is useful in the current market. So in computer system, when you allocate a CPU for process execution with the help of memory, so to allocate a CPU we use the queue. So whichever the job come first in the queue will get first CPU for the execution. Then in printer, the print request in spooler at the first location will get first response, right? And in general reservation counter ticket system or anywhere you are going to order something, so in that case we are using queue. So queue is also good type of data structure in general life you are using. So thank you for watching this video. Hope you are getting the concepts.